Students, while solving questions on integration, either they are from JEE or CET or from any other competitive exams, shortcut techniques are very important. Now, basically, what are shortcut techniques? Students, shortcut techniques are nothing but your theorems and your corollaries memorized very properly. So, in our today's lecture, we are going to see some corollaries on integration. So students, I welcome you all to my channel Pankaj Lade, your one-stop solution for mathematics. So let's see some of the corollaries of integration in our today's lecture. Student, the first corollary that we are going to see today is integration of f1 of x upon f of x dx is equal to log of f of x plus c. Now try and understand. When I say f1 of x, I basically mean the first derivative of f of x. So if you observe in the corollary, we have f1 of x, the numerator is f1 of x. The numerator f1 of x is the derivative of the function f of x. So the corollary statement is like this. Integration of f1 of x upon f of x dx is equal to log of f of x plus c. Now let's see how to get the answer for this particular corollary. Now students, please watch my previous video on substitution method. I have covered the entire theorem in my previous video about substitution. That is what concept I am going to make use in this particular statement also. In this corollary, I am going to make use of the substitution method. So observe carefully what I am going to do. We have, let us say, I is equal to integration of f1 of x upon f of x dx. So in substitution, I will have to identify a particular function which can be substituted with a new variable. In my case, in our corollary here, what I am going to do is substitute, say, f of x as t. Students, I am substituting the denominator f of x as t. So now if I say differentiate both sides with respect to x. Let us say differentiate both sides with respect to x. So what do I get? The derivative of f of x. It is going to be f1 of x. Isn't it? It is equal to dt upon dx. Now only for simplicity purpose, what I can do here is I can send this dx on the other side. Now students, this dx does not go on the other side because dt upon dx are not two separate terms. It is actually d by dx of dt. But as I said, for simplicity purpose, now we have already learned the previous theorem, the theorem of substitution. Over there we have already understood how this dx goes on the other hand side. So in this particular corollary, what I will do is, only for the sake of simplicity, I will say that dx I will transfer on the other side. But in actual, this will not happen. This has happened through the theorem. So for the theorem, you should watch my previous video. Now dx is set on the other hand side. So I can say f1 of x dx becomes equal to dt. So when I go back to my integral, if you observe the integral, you can see f1 of x dx here, isn't it? We can see f1 of x dx. So this f1 of x dx can now be substituted as dt, isn't it? And our denominator, which is f of x, for f of x we have taken the substitution as t. That means the integral can now be written as I is equal to integration of f1 of x dx. What is f1 of x dx taken as? dt. So I write dt here. So the numerator has been completely vanished from here now. f1 of x dx has become dt. So there is no numerator now. So whenever no one is present, there is always 1. So I have written 1. And in the denominator, there is f of x. And we know that f of x has been substituted as what? T. So 1 upon t. Students, you remember all the integration formulas. I have already taken all the basic formulas of integration in my previous videos. Make sure that you go and watch those videos as well. So from there, if you remember, integration of 1 upon x, integration of 1 upon x dx is log of x. So that is why integration of 1 upon t dt is going to be log t. Now, people, you want to remember that the log that is written over here is to the base e. Whenever we are doing any particular problem in calculus, that is derivatives, integration, limits, any other thing like that. So whenever we are doing anything from calculus and if a log comes, it is by default to the base e. You need not write it. So whenever integration is carried out and if the log comes, the log will be to what base? It will be to base e. So log of t plus c. But do you remember what was t? See, t is a variable that we have brought in the corollary, isn't it? T is a variable that has been brought by us in the corollary. So the resubstitution of t is mandatory. It has to be done. What is t then? It was f of x. So let's replace the t with f of x. So I get here log of f of x plus c. Isn't it a very simple corollary? It simply says in the numerator you should have the derivative of the function and the denominator should be the function. Numerator is the derivative of the function and the denominator is the function. Then the integration of such kind of a integral comes out to be log of f of x. Log of f of x, where f of x was the denominator. f1 of x is the numerator. So students, that's our first corollary. There are two more corollaries that we need to understand. So students, let's move on to the second corollary. In the second corollary, now we have integration of f1 of x upon root of f of x dx, and the answer comes 2 root of f of x plus c. Now, have you observed that the numerator is f1 of x and the denominator is root of f of x? That means this corollary also makes use of the same two terms which was used in the first corollary. In the first corollary, there was f of x and then there was f1 of x. In this corollary also, I have f of x and f1 of x. So students, if I take I is equal to integration of f1 of x upon root of f of x dx. So I'm going to make use of the exact same substitution that was used in my first corollary. In the first corollary, if you remember, what was f of x taken? It was taken as t, and then I have differentiated it and I have got the answer f1 of x dx equal to dt. So the same set of substitution can be used for the second corollary as well. Now, if you observe the numerator, it is f1 of x dx. So did you observe in our previous corollary, the substitution f1 of x dx, was it dt? So I can replace the entire numerator by what? Dt. So the entire space that is created over here has been completely replaced with dt. So I can say integration of dt. So this term has vanished and you have got dt. So I write 1 over here upon root of, student, what is f of x? F of x, if you see, f of x, was it t? So I can replace this f of x by what? T. So I will write here t. Again, students, formulas of integration is very important. Whatever question that you want to solve, be it anything, without formulas, nothing can be achieved in this particular chapter. You have to know your basic formulas, your standard formulas very well. Make sure that you keep on watching all my videos on integration. In my previous videos, I have already covered all the formulas of integration, all the standard functions. Make sure you watch them, learn the formulas of integration, and then proceed for solving the problems. So students, 1 upon root t is a standard function, and the integration of 1 upon root t, it is very much similar to 1 upon root x that we have learned in our formulas. So integration of 1 upon root x is 2 root x. So I can get here 2 root t, and I should never forget to put a plus c because we are doing indefinite integration. So 2 root t plus c. And what was t? T was f of x, isn't it, people? T was f of x. So I'm going to write here 2 root of f of x plus c. So students, that's our second corollary. So what was the first corollary? It was integration of f1 of x upon f of x dx. Integration of f1 of x upon f of x. f1 of x is the first derivative of f of x. Upon f of x dx becomes equal to log of f of x. Similarly, the second corollary that we have learned is integration of f1 of x upon root of f of x. So what's the difference between the two corollaries? Here the denominator is only f of x, whereas here the denominator is root of f of x. And the answer came 2 root of f of x plus c. That was our second corollary. Let's move on to the third corollary. So students, the third corollary again. So that was my second corollary and this was my first corollary. So let's move on to the third corollary. It is now integration of f of x raised to n, f of x raised to n, f1 of x dx. The answer is going to come f of x raised to n plus 1 upon n plus 1 plus c. Now students, did you again observe? In the third corollary also, I have the exact same two terms which were used in the first and the second corollary. That means I am going to make use of the exact same set of steps that were used in the first corollary in my third corollary also. So students, what was my substitution? I had f of x equal to t. I had f1 of x dx equal to dt. Let's go to our third corollary. Let's do the necessary substitution. What's the left hand side here? I have I is equal to integration of f of x raised to n into f1 of x. But I guess you have already noticed that this f1 of x dx that you see here. So f1 of x dx, if you remember, f1 of x dx was dt. So I can replace this f1 of x dx by dt. So I can write here integration of, what is f of x? From the substitution, what is f of x? It was t. So let's put f of x as t. So I t raised to n and then f1 of x dx was dt. Again students, what has happened? Again you need to know the formulas. Again we have a long list of formulas and knowing the formulas is a mandatory skill. You need to know your formulas to solve any question in integration. So again, if I observe here, this looks like integration of x raised to n. Students, you must be remembering that integration of x raised to n is x raised to n plus 1 upon n plus 1. So integration of t raised to n will become t raised to n plus 1 upon n plus 1 plus c. But students, as we know that t is the substitution that has been brought by us in the problem, isn't it? So that means we need to replace it back to the original variable. What was t if you remember? T was f of x. So I'm going to replace this t by f of x and answer comes f of x raised to n plus 1 upon n plus 1 plus c. So that's my answer. Observe f of x raised to n plus 1 upon n plus 1 plus c. So students, these three corollaries are so important that if you know them very thoroughly and if you are able to identify function and its derivative, so it's a combination of two concepts. You should know the function and its derivative and you should know these three corollaries. Many of the questions, students, many of the questions can be solved within one step. Within one step you can solve a lot of questions. So make sure students that you know your formulas of derivatives very well, you know these three corollaries very well and just combine them and solve as many questions as you can. Students, thank you so much for watching. I wish you all the very best. Have a great day.